Hello and welcome to my video presentation on selectivity enhanced by cascading. My name is Martin Hlavačka and in this video I will explain the selectivity method, how it works, its benefits and its application. What improves selectivity enhanced by cascading? This is another selectivity method that we deliberately separate from the third selectivity methods we talked about in the previous video, and you will soon understand why I did it. The selectivity enhanced by cascading is the use of the current limiting capability of upstream circuit breakers to allow the selection of the downstream devices with lower breaking capability. This approach requires precise coordination of limiting levels and tripping energy levels. This solution is the only one that achieves selectivity up to high short circuit current with a selectivity category A circuit breakers according to IEC 60947-2. How does the limiting phenomenon work? The current limiting capacity is that the default current is always decreased by the upstream circuit breaker current limiting capacity. The value of short circuit current flowing through the downstream circuit breaker is then much less than the calculated one. Let's move on to the next slide to dive deeper into this. This limiting phenomenon is based on arc energy levels. During a high short circuit current in the installation, first what happens is that both circuit breakers A and B detect a very high level short circuit current. Then circuit breaker contacts A and B open simultaneously due to the electrodynamic forces caused by very high arc energy. Upstream circuit breaker A experiences a limited short circuit current compared to its breaking capacity, but still this current induces contact repulsion. As a result, the arc voltage increases the current limiting at the circuit breaker A. The dissipated energy causes reflex tripping of breaker B, but is insufficient to trip breaker A. The current level is sufficient to fully open only circuit breaker B. In other words, circuit breaker A helps circuit breaker B trip without tripping itself. The selectivity limit can be higher than the ICU of circuit breaker B, and the selectivity becomes total with reduced cost of the devices. The benefits of the selectivity enhanced by cascading are that it provides not only continuity of service and safety, but also cost optimization of the installation. Cascading can decrease the cost of downstream protection devices by up to 40%. Selectivity enhanced by cascading can be applied in any electrical distribution system, in buildings, industry, data centers, energy, and infrastructure. This method is completely safe and it is allowed by the IEC standards. We come to the end of this presentation. Now you know how to promote service continuity with optimized installation cost. Thanks so much for watching. Stay tuned for the next video where I will talk about low voltage distribution.